So today I'm talking to Dr. Bonnie Buratti, who is a planetary scientist at NASA's Jet Propulsion Laboratory. Bonnie, thanks very much for speaking to me.
Thanks for having me.
Now, our paths have kind of crossed because you have a new book out, which I've actually got here. It's called World's Fantastic World, World's Familiar, and I suppose it's really a guide to the solar system via the various planetary exploration missions. Would you say that was a fair summary?
Yes, I would say that's a pretty good summary. I've tried to tell the story of the solar system through these planetary missions, some of which I've worked on.
Yes, that's right. You've worked on some of the most famous. I mean, you've worked on Cassini and New Horizons and Rosetta, and I also read somewhere that you worked on the Voyager missions. Is that true?
Yes, that's kind of where I cut my teeth. That was where I did my thesis, and that was where I first, really got in the thick of things and really participated in a mission and really saw how exciting it was. The icy moons of Saturn and Europa as well.
There's a great bit in the book where you kind of talk about the discovery of the plumes in Enceladus. Because there was a bit of debate for a while as to whether or not that's what had actually been discovered, wasn't there?
Yeah, I think that the story of the discovery of plumes on Enceladus really is kind of a paradigm of how scientific discovery works. You have two groups of scientists that disagree about something, and each holds on to its side of the story, and that is what propels science forward. There were scientists that believed, well, the plume wasn't really there, it was just an artifact in the images. And then there was another faction of scientists that was pushing forward to alter the trajectory of the spacecraft so that we could dive down close, breathtakingly close to Enceladus and see these spectacular plumes. The latter group won out, and we discovered plumes and activity on Enceladus.
Why was that so important? Why was it so important that we had discovered that?
Well, one of the themes of my book is to compare the Earth and the planets, not only planets in the solar system, but maybe planets in other solar systems. And we have liquid water on the Earth, and the search for life is really the search for liquid water. So we were looking for liquid water in other parts of the solar system. And if you have a plume, if you have jets coming out of Enceladus, that means there's liquid water underneath. And it's possible that this could be a location, a so-called habitable environment, a location for life, bacterial life probably, to form. That's why it was so key to what we were doing.
It does seem like a pretty hostile place for life to exist, though. I mean, as you say, if life does exist there, or if it did exist, it would likely be bacterial, wouldn't it? I mean, how likely is it that we could ever find anything a little bit bigger than bacterial within our own solar system?
Well, personally, I think it's unlikely, but we don't know. Every time we have visited a new moon or a new planet, we found something we didn't expect. Look at Pluto. We got to Pluto, and there's activity on this body that is frigid cold. I think that if you're looking for life, you're looking for three things. You're looking for not only liquid water, life as we know it, liquid water. You're looking for some type of energy and some type of food for the life to subsist on. So if we have an ocean underneath Enceladus or any other body, Europa also has an ocean underneath, and maybe Pluto, maybe some other moons, there is liquid water. We found organic molecules in the plume, in the jets coming out of the liquid ocean. So we have liquid water, we have food, and there's also energy. Otherwise, you wouldn't have liquid water because it's so frigid and cold out there that water is in the form of ice. But there is tidal heating in the interior of Enceladus. So we have a form of energy. So all the requirements for life are there. And it is possible. I want to emphasize we haven't found life, but it is possible that it is there. Now, your question about could we have anything beyond just simple bacteria? Well, we don't really know. If bacterial life forms as it did on Earth, it did, after millions of years become more complex. We just don't know the answer to that.
And I suppose in terms of talking about water being a sign for life, we have to discuss Mars, because even in the past kind of few months, we keep kind of discovering more evidence of water having existed in Mars's ancient history.
Yes. In fact, Mars is the other intriguing object in the solar system. And I kind of followed the story of life on Mars as a child, as really as an outsider, not as a scientist. And, I can remember as a kid seeing all these experiments that scientists were doing that showed that, primitive life could exist in the conditions that existed on Mars. And when Mariner 4 in 1965, I was just, a child then. In 1965, Mariner 4 was the first spacecraft to go by Mars. When it went by, it was just devastating because it was just a cratered world. But it only looked at a snapshot of the Martian surface. As more spacecraft were sent back, we realized that Mars was much warmer and wetter in the past. It was more Earth-like when it first started out. And since life arose on Earth almost immediately when it could, we think that life may have also arisen on Mars. And as it lost some of its water, it doesn't have as much gravity as the Earth. So a lot of this water became vapor and then escaped. But the life that was there may have hunkered down in the subsurface of Mars, where we think there is a huge amount of water in the form of ice. And just like on Earth, we have these odd organisms called extremophiles that can live just about anywhere, even in boiling water, in caves, deep down in the earth, up in the atmosphere. So on Mars, these hunkered down bacteria could be living under the surface of Mars. And as you said, there is evidence that this icy material actually becomes liquid water periodically.
But is it completely out of the question that at one stage Mars could have supported things like plant life or anything like that? Like, is there anything to kind of suggest that?
There isn't anything to suggest that. We do have this Martian meteorite that has what scientists have shown could possibly be a bacterium. It had all the hallmarks of it, but it could also be something inorganic, something that was created not from life. But in terms of plant life, it doesn't look like that kind of complex life ever arose. There were oceans on Mars. There's pretty good evidence for that because we can see shorelines in the northern pole of Mars. It does look like there was a giant ocean, but there isn't any evidence that we had plant life in the past.
And I suppose all this kind of search for life, it kind of ultimately takes us back to life on our own planet and where that life might have came from. Where do you stand on a theory that life on Earth may have begun somewhere else? May have begun on a different planet on our solar system and then somehow been transferred across to Earth?
Yeah, there is that theory called panspermia, where you take amino acids or maybe even bacteria, primitive life that is brought to the Earth by a comet or an errant asteroid, somehow that still exists in the center, in the interior of one of these small bodies and just gets transported to Earth. And, I'm not a biologist, so I'm an astronomer. It's hard for me to really make judgments about the origin of life. But I think the consensus right now is that life arose in the deep ocean trenches. There are these plumes of hot water that come out called smokers, where right now we see primitive life there, primitive bacteria that seems to be connected to life on Earth. It's kind of our ancestor. And the interesting thing about these smokers, these plumes of hot water that come out of the oceans, we think they may also exist on bodies like Enceladus or Europa. There is evidence that there are such kind of hot water spouts that come out that could also be a location for primitive life to arise, just as it did on the Earth.
I also wanted to discuss with you the concept of a planet 9. It's something that kind of keeps coming up because there keep being various discoveries or scientific theories that kind of suggest that there could be a planet 9. In your kind of research and work, how likely do you think that there is other stuff beyond Neptune that we've yet to kind of see?
Well, first of all, I think Pluto is a planet. So I think Pluto is planet 9. But to answer your question, there will be other large objects like Pluto discovered in the outer solar system. We've already discovered one called Eris, which we think may even be active because it's very bright. But there is some work that my colleague Mike Brown and others are doing that suggests there might be another larger object out there, a planet-sized body. And we don't know for sure. There's some perturbations or little tugs and pushes on some of the other small objects in the outer solar system. There's kind of this large asteroid belt at the orbit of Pluto and beyond called the Kuiper belt. And there are thousands of objects in that Kuiper belt. And some of them look like they might be being tugged on by something larger. But again, we don't know. Many astronomers are looking for this object. In the next maybe 5 years, we'll know about that. But it's a thing where scientists disagree, and disagreement propels science. Scientists are moving forward because they don't agree about something.
Speaking of disagreements, you mentioned Mike Brown there, who of course is kind of the man who's seemingly held responsible for Pluto's demotion. But you yourself consider it a planet. Is there? First of all, I'd be interested to know why you think it's a planet, and second of all, do you and Mike Brown ever have any kind of heated debates on the subject?
No, it's all very collegial. I mean, first of all, scientists, we're interested in questions, the big questions. Take, for instance, Pluto. I mean, personally, I think it's a planet. Why? Because it's got 5 moons, it's got an atmosphere, it's round, it's got activity on it. I mean, it's way more than something that isn't a planet. But, at the end of the day, these kind of questions aren't really that important. What you call something. I mean, I would almost argue that Titan, this kind of Earth and deep freeze that orbits Saturn, is a planet. They're planet-like bodies in the solar system that aren't really planets. But, it's in a sense, it's somewhat arbitrary. But personally, I believe Pluto has so much on it, so much going for it, that it should be considered a planet. Also for historical reasons, I think it should be. I mean, the children of the world were really disappointed when Pluto got demoted. Pluto was one of my heroes when I was a kid.
Yeah, I mean, I can still remember being in, I guess it would have been maybe physics class, and I remember learning all the planets, and yeah, like when I was a kid, Pluto was a planet. But one of the really good things about your new book is you kind of provide it's not just all kind of planetary science. You kind of provide the human experience behind these planetary missions, and I was kind of wanting to gauge from you, what's it like working on one of the teams, like New Horizons or Cassini? Is there kind of a real sense of bond between the members? And I've also because most of the planetary probes seem to end their life being purposely crashed into the planet they're studying. Is there a sense of regret and kind of sadness once the mission's over? How do these missions actually work in terms of the humans' experience?
Well, I think that space science and exploration is, the greatest thing you can be involved in. So there is a great bond. Many of the scientists that I work with, they're almost like brothers and sisters. It's really a bond. It's a brotherhood, a sisterhood. So there is definitely, I mean, there are conflicts. Sometimes controversies or disagreements do boil over into the personal, but usually it's just all part of the process. We recognize that disagreement does propel science, drive science. But the missions themselves, when they come to an end, and one of the things I point out in my book is that most spacecraft do come to an end. NASA, and I think also the European Space Agency, like to end projects so other ones can come to life. That's the main thing. There's only so much funding. And I was at the Rosetta landing on the comet that it was studying, and it was really emotional because this group had been working together for really more than a decade. And to see the spacecraft that, we all knew and loved just end its life. It didn't crash. It's still on the comet. They are safe and sound, but the mission itself ended. And I'm going to be facing another situation in about a year when Cassini crashes into Saturn. We're going to see this gallant spacecraft that we've known and loved for over a decade. It's explored Saturn for over a decade, just dissolved into the stuff of Saturn. It's going to be very emotional. I mean, people cry when this happens.
What is the reason for that, for crashing the probes into the planets? Is there some scientific reason, or is that just the kind of easiest, cheapest way of doing it?
Yes. Well, there are scientific reasons, and there's the immediate object that you have to end a mission. But we also disagreed on Cassini how we were going to end this mission. The people that are interested in the planet Saturn and its magnetic field wanted to crash into Saturn because you get up really close and personal and get to see the atmosphere and the magnetic field. Whereas those of us that studied satellites wanted to go in this eternal orbit so that you would see Enceladus and Titan. Titan is this Earth-like object, Earth and deep freeze kind of around Saturn. But the atmospheric people won out, possibly because it would really end the mission. So there is that scientific reason that you get to see the atmosphere and magnetic field of Saturn very, very close.
Do you think that Venus has been overlooked? I've kind of heard a few people, even over the past few weeks, somehow it just kind of came across my consciousness. People kind of saying that maybe we need to explore Venus a bit more. It's a crazy kind of hell-like planet, and it would be very interesting. Are there any plans that you know of to send another probe to Venus, or do you think we should?
Right now, there aren't. I think that Venus is really ripe for exploration because Europeans had a spacecraft there, but the last spacecraft mission we did was Magellan, which was 15 or 20 years ago, where we mapped Venus, but we haven't gone back. I think that in many senses, Venus is the planet that we have the most to learn from because it looks like there was a runaway greenhouse effect there, where carbon dioxide just took over and caused the temperature to go up. It's hotter than an oven there. So definitely life as we know it could not exist. Although some people say there might be some primitive life in the upper atmosphere. But I think it is time to return to Venus. Right now, NASA is really pushing to explore what we call ocean worlds that have oceans either on the surface or underneath because it's connected with life. I think Venus has been overlooked because it doesn't have that potential for life right now.
And of course, in terms of looking for places suitable for life, I mean, we just recently had the TRAPPIST-1 discovery, and exoplanet discovery has really taken off, and even just kind of in the past 5 years. Is there any chance that within our lifetime we would be able to at least begin sending probes to exoplanets to see better what they look like?
Well, I think sending probes there is not the way to go because I'll take, for example, TRAPPIST-1. It's about 40 light years away. That means it would take light, which is so fast it can go around the Earth 8 times in 1 second. It would take light 40 years to get there. So even with our own spacecraft, it would take thousands of years. Our current spacecraft would take thousands of years to get there. So the way to do it is by ground-based exploration, ground-based telescopes, or telescopes in orbit. I think that the very important point here is that spacecraft have to be in concert with ground-based and orbiting spacecraft in order to get the biggest bang, the biggest fountain of knowledge. In the case of exoplanets, most of them were discovered by Kepler, which is in orbit around Earth. It had a 7.5-year mission and discovered thousands of exoplanets, about 20 or so were Earth-like. And extrapolating from the results, we think there are about 10 billion Earth-like planets in our galaxy alone. Our galaxy, the Milky Way, has about 100 to 200 billion stars, but around those stars, we believe there are 10 billion Earth-like bodies.
Yes, and whenever that kind of term Earth-like bodies comes up, it quite often is in kind of mainstream media and press because there has been a big collection of exoplanets discovered. But I suppose a lot of people perhaps feel a bit cynical about the kind of overuse of that term. Is it actually likely that we would be able to find a Earth 2.0, as they call it, somewhere that we could potentially go to and establish a new life there?
Well, we'd have to first of all explore it from ground-based telescopes first to really understand it. And I think this is where we're really crossing a threshold. Up until now, we were simply cataloging, discovering exoplanets. But now we're on the threshold of physically characterizing them. We're looking for atmospheres. We've already discovered water vapor and methane around exoplanets. Of course, the holy grail is to find oxygen. Now, just the existence of oxygen does not necessarily mean life, because there are other chemical processes that can produce oxygen, but it will be a good start. For example, let's take the TRAPPIST discovery, where 7 planets that are about as massive as of the Earth and are in this location called the habitable zone, sometimes called the Goldilocks zone, where liquid water exists. There are 7 just in that. Well, there are about 3 or 4 in the habitable zone, and there's some that are kind of on the edge. But scientists are going to go full bore on trying to look for atmospheres around these bodies, trying to understand what their composition is, more about their orbital characteristics. Do they have moons? We're starting to really answer these questions. And when we know the answers to those questions, then we can think about exploring them further, sending a probe there. But again, it would take thousands of years with our current technology to get to these Earth-like planets.
Yeah, so it's either a case of waiting for 1,000 years, or somehow managing to create something that can actually travel there in that time, which is probably kind of out of the question at the moment.
Yes. It would. I mean, there are all these science fiction stories about spacecraft going to exoplanet, going to other solar systems, and some of them deal with the fact that while the humans in these spacecraft are traveling, they forget even where they came from, because human memory only lasts so long, and there's a danger that if we would launch a spacecraft, that people after a while would forget about it, because civilizations rise and fall, and it's just. I'm an advocate of studying these bodies very well from the Earth before we even think about going there. I think right now, if we want to establish a civilization some other place, probably Mars might be the place to go to. There are some scientists that have this interesting idea of terraforming Mars, that is trying to force it back into the condition it was, the wetter, warmer condition it was earlier in its history. And there is a group of scientists that advocate doing that, bringing its atmosphere back and melting the water underneath the surface. It would be quite a feat, quite a technological feat.
One of the things I always like to ask people like yourself who are who work at JPL and kind of work in planetary science and at NASA is, do you still find time to take a telescope out by yourself and actually do some practical observing just for your own sake?
I do. I love to do star parties with the public. If I give a lecture someplace, I always like to follow it with going out and just looking at the stars. And one of the things I have a little toy telescope that I occasionally take out. And many astronomers do have their own telescopes that they view with. And some of my colleagues even build observatories in their backyards. But one of the things I like to do when I'm in an area, when I'm at a large telescope like the Palomar, the 200-inch in Mount Palomar, if I'm taking a long observation, I just like to go outside, and where the sky is so clear, I just like to look up. And like when I was a child, what got me into this, I look up and just wonder at the heavens, wonder at these marvels of the universe. And I like to look at the things I can't see in my home near Los Angeles because it's so murky, so bright. But no, the sense of wonder has never gone.
And in terms of your career and your work at NASA, what's next? Are you? I suppose you're kind of seeing out the Cassini mission, but then what's coming up in the future?
Yeah, well, NASA really has an ambitious program that is centered around ocean worlds. The thing that we're going to do next is explore Europa. This is an object very similar to Enceladus. We're pretty certain it has, as certain as you can be in science, it has a subsurface ocean. It has a crust of ice over it of many kilometers. So you have to kind of drill down, but we're looking for plumes, for some type of jet, some type of activity. We've found them a couple times from the Hubble Space Telescope. It seems to be sporadic. I mean, if you look at Enceladus, this plume is bursting at the seams, all the time. But on Europa, the moon of Jupiter, it seems to be more sporadic. It kind of like puffs out every so often. So that's the next object we're going to plan a mission to. And then after that, maybe we'll go back to Titan or Enceladus. But we're focusing on these ocean worlds.
Fantastic. Well, Dr. Buratti, thanks very much for talking to me. I really, really enjoyed talking to you. It's been fascinating.
Thank you so much. It's been my pleasure.